Step 1 when multiplying a monomial to a polynomial. That's step 1. Step 2. Combine like terms. Now that should sound familiar because adding and subtracting polynomials, what were the 2 steps? So we're doing literally the exact same steps. Yep. Doing the exact same thing we did yesterday. Okay? So, step 1, distribute. Get rid of the parentheses. So I will take that monomial, or that single-termed expression, and distribute it to the binomial, in this case, because it's a polynomial with 2 terms. Bi means 2. Okay? When I do 3 times x, what do I get? 3x. Scratch out that because I'm done with it. When I do 3 times 2, what do I get?
6.
Yeah, that's it.
Is this all we do?
Yep.
Like I said. That's so easy.
Basically more practice. Okay? However, what is slightly new is the monomial that you distribute may have a variable with it, and we need to understand how that works. Okay? I'm still going to do the exact same process. Distribute and then combine like terms. So I'm going to distribute the 2x to the x and the -1 inside the parentheses. The way I suggest you do it, first and foremost, is take care of the number values first. Okay? So technically this is 1x. So I'm going to take care of the numbers first. What's 2 times 1? 2. Okay? I have x and I'm multiplying by another x. So x times x. Remember when we talked about our exponent property rules, when you multiply 2 variables of the same letter, what do you do to the exponents? Add them. You add the exponents together. So the base stays the same. X, what's 1 plus 1? 2. So x times x is the same thing as saying x squared. That is just taking our exponent property rules, which you took a midterm over, and the Unit 6 test over, okay, and just putting it into polynomials. Now I have done the first term of the parentheses. Now I'm going to do the second term of the parentheses. Remember, what do we take care of first? The numbers within the distribution. So it's 2 times -1. -2. X, is it being multiplied to? Is there another variable to multiply it to? No. So guess what? You just rewrite it. Man, that was hard.
So wait, so how do you get the 2 there?
So the x times the x times x, when you multiply 2 variables of the same letter, the exponents with them, they don't have exponents, so you assume it's the number 1. When you multiply 2 variables, you add the exponents together. Boom. All right, let's look at number 5. Look at number 5. I'm going to distribute this monomial to this binomial because there are 2 terms within that parentheses. What do we take care of first? The numbers, okay? -6 times what is technically in front of that letter P? 1. So it's -6 times 1. -6, correct. I have P times P to the power of 4. That should look like this. P times P to the power of 4. Okay? So if I look at this, I have p to the power of 1 times p to the power of 4. Multiplying variables of the same letter, what do you do to the exponents? Add them. So I should get p to the power of 5. 4 plus 1 is 5. Okay? I'm done with that first term in the parentheses. Now I distribute to the negative 8. Always take care of the number part of it first. Negative 6 times negative 8 is positive. What's 6 times 8? There you go, 48. Now, is there anything to multiply to the letter P? No, but it doesn't disappear. It must still be there, so I put it right there at the end. Very complicated stuff. Okay. Y'all will now attempt 6 and 8, and then we will spin the wheel of not ideal. I circled them. 8 just has one more term to distribute to. Process still the same. You distribute across.
This one does not have a C on it, then I don't have to put
Are you distributing a C though?
yeah.
So the C that you are distributing now goes to it.
So then that would be right with the C and then 7 because there's
Did you
5.
distribute 1 C or did you distribute C to the power of 5?
C to the power of 5.
What did you distribute?
Okay, but like 7 would be right because there's 2 of the C. Negative 2C right here.
No. That negative 2 goes with the big numbers. Big numbers go with big numbers, small numbers go with small numbers. Is there a small number with that C?
No.
So if there's not, you assume what number it is.
5.
One.
Or
1. Okay. And then you add the exponents together.
So then, okay.
So it wouldn't be 7, it would be
Just 6.
6. As the exponent. couldn't wait one more, like... Is that your lunch? I was going to say, it's not even 10. Ah, cake.
Again?
The wheel is just. You must not question the wheel. The wheel is unquestionable. It is all knowing. It is all knowing.
Isn't though. So am I. Oh! How did you miss my mic? You finish. Next week. We'll be away.
Oh, I'm looking at the wrong page. That is correct. Thank you, checkers. The wheel is just. We must believe in the wheel.
Oh my god. Where are you?
I'm not joking. That literally is what just happened.
Wait.
That is correct. The wheel is just. We must not judge the wheel. Sweet. Turn the page. Good job. Everyone skip to number 13. Everybody skip to number 13. 13. There's a reason why I'm skipping to 13. Not because of the numbers. Because there are multiple variables, correct? AKA there's not just X or not just Y. X and Y are both in the problem, correct? So let's talk about it and explain how this is going to work. Now, our steps will not change. We will distribute and then combine like terms. So this is how it's going to work. I have a monomial or a value outside of the parentheses here, and now I will distribute it to there, okay? There are only two terms that I am distributing to, all right? This negative 4x squared y is all one term, okay? So here, what do I tell you to deal with first? The number. So what is 2 times 6? 12. So I have 12. Okay. The variables x and y, are they the same letter? No. So can I do the product of a power rule where I add the exponents? No, because they're not the same letter. Good. So what I do is I just write them next to each other to show multiplication, and I write them in alphabetical order.
Does it really matter if it's in
Yep.
alphabetical order?
Yep. Because that's X is before Y. X, Y, Z. All right, so we have now distributed to the first term. We must now distribute to the second term. But again, what do we always deal with first? The numbers, okay? So what is 2 times negative 4? Negative 8, okay? Now, when I distribute the y to the variables, can it go with the x? No, so I just rewrite the x squared. However, it can distribute to that y that is also attached to that negative 4. What is y times y? Y squared. Okay, y squared. So now I've distributed to both terms in the parentheses. Do I have any more parentheses to distribute to? No. So whatever I have left over, I just drop down. Okay. Now, again, our rules are distribute and then what? Combine like terms, right? Do I have any like terms in this problem up here?
Yeah.
Not lots,
2.
just 2. Okay? I have this one here and this one here because they are the only ones with similar variables. Okay? So if I have negative 8 and I add 13 to it, what do I have?
5.
Cross those out because I am now done with them. I used them. I don't want my ADD brain to look at them anymore. Okay? Remember, when we do this, it must be in descending order, so the higher exponents go first. This has a total of 4 exponents, 1, 2, 3, 4. This one has a total of 2 exponents, and this has 0 exponents. So between 12 and 6, which one goes next?
12.
The 12. Good.
Do the exponents on the x and y on the first one not turn to 4?
No, because they cannot combine. They look, so this is a question that's come up 3 times already, okay? Here's how this works. Here's what I try to tell myself, okay? The only possible way to change an exponent is with multiplying, dividing, or distributing. It's the only way an exponent will change. If you add or subtract, the small numbers cannot and will not change. Does that help a little bit? Okay, so the only time an exponent can change is with multiplying, dividing, or distributing. Okay? All right, so now that that's done and we have that practice done, all right, I'm going to give you 3 examples here that I want you to work that are, as you can tell, are longer problems with multiple distributing, but the processes are still the same. But luckily, they're all single-valued variables. I want to do 12 and 10. 10 and 12. 10 and 12. Those are the 2 that I want y'all to practice.
for this one, when we add the numbers, this one and this one, we're subtracting, right? So is it like, this would be 12 minus 10 would be 2x, and then would the exponents also subtract each other? So then it'd just be
Brett
2x.
asked that question,
Okay.
and I said there's only one possible way for exponents to change. And what are those three? Sorry, I'm going to say one. What are the three different ways an exponent can change?
By adding, subtracting.
There are only three ways an exponent can change. What are those three ways? Well, you said adding and subtracting. I didn't say correct. So what are the other operations that we have?
Dividing, multiplication.
And distributing. Okay.
So it won't change.
No, because all you're doing is adding and subtracting.
Okay, so then there'd just be 2x squared. Thank you.
Did you walk all the way up to my desk and then do the hand sign for the restroom? You didn't just do this? It looked like you did that.
I was stretching. Maybe I used to listen.
You have 2 minutes. That should be plenty of time because the bathroom is literally across the hall. Number 10. Riley was literally less than a millimeter away from being picked. Whoops. That is perfect. Awesome. Way to go. Good job. That is correct.